In late 2021, astrophysicists discovered primordial dwarf galaxies hosting supermassive black holes that are mathematically impossible according to our standard models of cosmic evolution. These black holes are overmassive, occupying up to 60% of their galaxy's total mass compared to the fraction of a percent we see today. How did these cosmic monsters get there before their houses were even built? Today we are unraveling the mystery of the little red dots, an astronomical anomaly that is fundamentally rewriting the history of our universe. When you look at the universe as a whole, the cosmic neighborhood that includes our Milky Way, Andromeda, and thousands of other mature galaxies, there is a profound and comforting order to things. At the center of almost every large galaxy lies a supermassive black hole. For the Milky Way, that is Sagittarius A star, a sleeping giant weighing about 4 million times the mass of our Sun. 4 million sounds incredibly heavy, but compared to the total mass of the Milky Way, it is practically a rounding error. For years, astronomers observed a strict, unbreakable mathematical correlation known in astrophysics as the Magorrian relation. It dictates that a central supermassive black hole will almost always account for roughly 0.1 to 0.5% of its host galaxy's central bulge mass. Think of it like the relationship between a human being's total body weight and the weight of their heart. A healthy human heart scales proportionately with the body it pumps blood for. In the cosmos, the black hole is the heart and the galaxy is the body. Because of this precise mathematical ratio, scientists developed a logical, step-by-step theory of cosmic evolution. They believed that galaxies and their black holes grew up together, locked in a slow, billions of years long dance called coevolution. According to this model, in the very early universe, a baby galaxy forms from a halo of dark matter and swirling gas. Inside this baby galaxy, the first generation of massive stars live fast and die young. When they explode in supernovas, they leave behind tiny, stellar mass black holes, seeds weighing maybe 10 to 50 times the mass of our Sun. Over billions of years, as the galaxy slowly gathers more gas, dust, and stars, these tiny black holes merge together, feeding on the cosmic scraps falling into the galactic center. Slowly, steadily, the heart grows along with the body. This was the textbook standard. It made sense. It obeyed the laws of physics as we understood them. And when the James Webb Space Telescope launched on Christmas Day in 2021, astrophysicists were excited to finally look back in time and prove it. Because light takes time to travel through space, looking deep into the cosmos means looking back into the past. JWST was designed to see the universe's awkward adolescence. Astronomers expected to point the telescope at the deepest, oldest corners of the void and find tiny, fragile baby galaxies hosting tiny, fragile baby black holes. It was supposed to be a neat, comforting confirmation of our science. But the universe, it turns out, has no interest in comforting us. When the first deep field data beamed back to Earth, the textbooks were immediately rendered obsolete. The early universe was not slowly growing up, it was already harboring monsters. The inciting incident of this cosmic mystery began as a smudge on a screen. When scientists began analyzing JWST's near-infrared and mid-infrared imagery of the early universe, looking at light that had been traveling for over 12 billion years, they noticed something entirely unexpected. They didn't just find one or two anomalies, they found an entire population of bizarre objects that didn't fit any known category. They playfully dubbed them little red dots, or LRDs. But there is nothing playful about what these objects represent. At first glance, LRDs appear as incredibly compact, intensely red point sources of light. Because of the expansion of the universe, light from the dawn of time gets stretched out into longer, redder wavelengths, a phenomenon known as redshift. JWST was built specifically to see this invisible infrared light. But when researchers isolated the light from these little red dots and spread it out into a spectrum, a technique called spectroscopy, they found a signature that made absolutely no sense. When you look at the spectral energy distribution, or SED, of a little red dot, it forms a bizarre, contradictory V shape. One side of the spectrum, the ultraviolet side, is blazing, chaotic, and fiercely blue. The other side, the optical and infrared side, plunges into a deep, shrouded red. To an astrophysicist, this is like finding a creature that is simultaneously freezing cold and boiling hot. The blue ultraviolet light carries broad emission lines, specifically of hydrogen. In the language of astrophysics, broad hydrogen lines mean gas is swirling around at terrifying velocities, thousands of kilometers per second. There is only one thing in the universe capable of whipping gas around that violently: the intense gravitational well of an actively feeding supermassive black hole. But the red side of the spectrum tells a completely different story. The extreme redness indicates that this object is deeply obscured by a thick, suffocating blanket of cosmic dust. This created a bitter debate in the astronomical community. How can an object be a naked, blazing quasar and a hidden dust-choked stellar nursery at the exact same time? Some scientists argued that the little red dots weren't black holes at all, but simply ultra-dense pockets of extreme starburst activity. Millions of stars being born at once, shrouded in the dust of their own creation. Others argued that they were supermassive black holes, but couldn't explain how the light was escaping the dust. The breakthrough came when we realized this was a trick of cosmic geometry. The little red dots are essentially cosmic engines tilted on their side. Imagine a brilliant blue roaring fire surrounded by a thick donut, a torus of black smoke. If you look at the fire from the top down, through the hole in the donut, it is blindingly blue. But if you look at it from the side, through the thick wall of smoke, the light struggles to get through, turning a deep, eerie crimson. The little red dots are shape-shifting monsters, actively feeding black holes hidden behind chaotic, swirling walls of dust. But solving the riddle of their color only unleashed a much more terrifying problem: their size. Recent papers and observations have zoomed in on specific dwarf galaxies in the early and intermediate universe, galaxies with names like Peleus and Neleus. A dwarf galaxy is exactly what it sounds like: a small, faint collection of stars. By cosmic standards, Peleus and Neleus are minuscule. Their total stellar mass, the combined weight of every single star inside of them, is only about 10 million times the mass of our Sun. For context, our Milky Way has a stellar mass of about 60 billion solar masses. Remember the Magorrian relation? The unbreakable rule that a black hole should only be 0.1% of its galaxy's mass. If that rule holds true, a dwarf galaxy with 10 million solar masses of stars should host a central black hole weighing roughly 10,000 solar masses. But when JWST analyzed the broad emission lines of these galaxies to weigh their central black holes, the math collapsed. The black holes hiding inside these tiny, fragile dwarf galaxies didn't weigh 10,000 solar masses. They weighed millions of solar masses. Instead of making up a fraction of a percent of the galaxy, these black holes accounted for 6%, 10%, and in some extreme little red dot cases, up to 60% of the total mass of the entire system. This is the nuclear reactor inside the mud hut. It is an absolute paradox of cause and effect. If a black hole forms from the collapse of a dying star and grows by slowly eating the material around it, how can a giant black hole exist before the galaxy has even had time to form a significant number of stars? You cannot have a heart that weighs more than the body. You cannot have a black hole that is essentially older and vastly larger than the galaxy that supposedly birthed it. This discovery sent shockwaves through the scientific community. It meant that the stellar seed theory, the idea that supermassive black holes grew slowly from the corpses of normal stars, was fundamentally wrong, at least for the early universe. The timeline just doesn't work. The universe wasn't old enough at the time these little red dots existed for a stellar black hole to feed and grow into a million solar mass monster. Even if the black hole fed at the absolute maximum physical speed limit constantly since the Big Bang, it still wouldn't have enough time to get this big. The monsters didn't grow inside the house. They were there before the foundation was even poured. But just as theorists were scrambling to invent new physics to explain this, the little red dots threw another wrench into the gears. The monsters were missing their shadows. In astrophysics, there is an ironclad consequence of gravity and friction. When a supermassive black hole eats, it doesn't just swallow matter cleanly like water down a drain. Matter falls toward the black hole, caught in its gravity, and begins to orbit, flattening out into what is called an accretion disk. As more and more gas and dust pile up, The material in the disk rubs together. This extreme cosmic friction heats the gas to millions of degrees. When gas gets this hot, it emits radiation. Specifically, it emits high-energy X-rays. For decades, whenever astronomers wanted to find a feeding supermassive black hole, known as an active galactic nucleus, or AGN, they didn't look for visible light. They looked for the screaming beacon of X-rays piercing through the cosmos. So naturally, when JWST discovered these little red dots, these impossibly massive, violently feeding black holes, scientists immediately turned to NASA's Chandra X-ray Observatory. They pointed our most sensitive X-ray instruments at these primordial monsters, expecting to be blinded by the high-energy radiation of their chaotic feeding frenzy. Instead, they were met with an unsettling dead silence. Imagine standing outside the doors of a roaring, packed sports stadium. You know the stadium is full. You can see the blinding lights pouring out from the open roof. You can feel the ground shaking beneath your feet from the stampede of tens of thousands of people. But when you press your ear against the concrete wall, you hear absolutely nothing. Total silence. This is the X-ray deficit problem. JWST can clearly see the broad hydrogen lines proving the gas is moving at thousands of kilometers per second. The gravity well is there, the heat is there, the black hole is undeniably feeding. So, where are the X-rays? How can a monster this big, eating this aggressively, be completely invisible to X-ray telescopes? The answer lies in a phenomenon that highlights just how violent the early universe truly was: super-Eddington accretion. There is a speed limit to how fast a black hole can eat, known as the Eddington limit. If a black hole pulls in matter too quickly, the sheer intense radiation generated by the friction of the accretion disk will actually push the incoming matter away. Gravity pulls it in, radiation pressure blows it out. When these two forces balance, the black hole is feeding at the Eddington limit, but the little red dots are breaking the limit. They are in a state of super-Eddington accretion. They are gorging themselves so fast and so violently that the standard geometry of the accretion disk breaks down. Instead of a flat, glowing plate of gas, the influx of matter is so overwhelming that the disk essentially bloats. It puffs up into a massive, geometrically thick wall of hyper-dense gas and dust. The black hole is choking on its own food. It is producing massive amounts of X-rays at its very core, just outside the event horizon, but the bloated, puffed-up accretion disk acts as a physical lead shield. The X-rays are trapped. They bounce around inside the thick cloud of gas, losing energy until they are finally absorbed and re-emitted as weaker, longer wavelength infrared light. The exact red light that JWST is seeing. The little red dots are silent in X-rays, not because they are dormant, but because they are feeding with such unimaginable gluttony that they have buried themselves alive in a wall of their own fuel. But this still leaves the ultimate question unanswered. We know what they look like. We know how they are hiding from our X-ray telescopes. We know they are mathematically too massive for their tiny galaxies. But how did they get there? If there wasn't enough time in the history of the universe for them to grow from dead stars, how were they born? The answer to the mystery of the little red dots is not a correction of our old theories. It is a terrifying, paradigm-shifting new theory known as the direct collapse black hole, or DCBH. To understand direct collapse, we have to travel back to the very first moments after the cosmic dark ages, before the first stars ever ignited. The universe back then was completely pristine. It was composed entirely of hydrogen and helium, the lightest elements forged in the Big Bang. There was no carbon, no oxygen, no iron. In astrophysics, anything heavier than helium is called a metal, and these metals are forged exclusively inside the cores of dying stars. Because no stars had died yet, the early universe was metal-free. This is a crucial detail. When giant clouds of gas gather in space today, the metals inside the cloud act as a cooling mechanism. They radiate heat away, allowing the cloud to fragment into thousands of smaller clumps, each of which collapses to form a normal-sized star. This is how stellar nurseries work. But in the primordial universe, without those metals, the giant clouds of pure hydrogen couldn't cool down efficiently. They couldn't fragment easily. Imagine a colossal cloud of pristine gas, hundreds of thousands of times more massive than our sun, sitting in the dark of the early universe. As gravity pulls it inward, it doesn't break apart into smaller pieces. Instead, the entire cloud collapses as one single monolithic structure. The gravity becomes so intense, and the sheer weight of the hydrogen is so crushing that it bypasses the star formation phase entirely. No star is ever born. No supernova ever explodes. The gas cloud simply caves in on itself, collapsing directly from a nebula into a singularity. In an instant, a direct collapse black hole is born, and it doesn't start as a tiny 10 solar mass seed. Because the entire massive cloud collapsed at once, this newborn black hole starts its life weighing 10,000 to 100,000 times the mass of our sun. This is the brilliant, terrifying answer to the little red dots. The monsters didn't grow inside the houses. The monsters formed first. In the chaotic environment of the early cosmos, these massive direct collapse seeds acted as gravitational anchors. Their immense pull began dragging in the surrounding dark matter and gas, eventually forcing the formation of stars around them. The black hole didn't evolve from the galaxy evolved around the black hole. This beautifully explains the impossible ratios of Peleus, Neleus, and the little red dots. When JWST looks at these overmassive anomalies, it isn't seeing a glitch in the math. It is seeing a direct collapse black hole in its infancy, rapidly gorging itself on the surrounding primordial gas, while its host galaxy is still struggling to form its very first generations of stars. The discovery of little red dots and the vindication of the direct collapse theory is a watershed moment in human history. It is the astronomical equivalent of discovering that the dinosaurs didn't evolve from reptiles, but simply materialized from the Earth fully grown. It forces us to accept that the universe operates in phases, and the rules of physics during the dawn of time were vastly different from the rules we observe outside our window today. The slow, patient coevolution of galaxies and black holes that we see in the local universe is a privilege of a mature, metal-rich cosmos. But in the beginning, the universe was a place of brute force and catastrophic, instant creation. This revelation also brings a profound sense of humility to science. For decades, we modeled the universe in supercomputers, writing elegant equations to explain how Sagittarius, A star, ended up in the center of the Milky Way. We assumed we had the timeline figured out, but the James Webb Space Telescope, a golden mirror suspended 1,000,000 miles from Earth, reminded us that the universe is under no obligation to make sense to us. The little red dots are not just anomalies on a graph. They are the fiery crucibles that forged the architecture of the modern universe. By studying them, we are quite literally looking at the ancient violent seeds of our own existence. If a direct collapse black hole hadn't formed in our cosmic neighborhood over 13 billion years ago, the Milky Way might never have possessed the gravitational anchor needed to gather its spiral arms. Without that anchor, our solar system might never have formed. Every time we look deeper into the dark, the universe proves to be stranger, more violent, and more awe-inspiring than our wildest theories could predict.